Hello friends, welcome back to the second part of Hill Cipher. In the previous video of Hill Cipher, I have already explained you how to solve a problem where Hill Cipher is involved, means how to encrypt your plaintext and how to decrypt your ciphertext using Hill Cipher. So in the last video, I have showed you an example where my key order was 2 by 2. Now in this video, I will show you another example where I am taking key matrix of order 3 by 3. So let's say my key k is equal to 10, 5, 12, okay, 3, 14, 21, and 8, 9, 11. Okay, so this is my key and I want to encrypt a plain text X which is crypto. Okay, so if you will see the table, your value for C is 2, R is 17, Y is 24, P is 15, T is 19, O is 14. Okay, so as we know that if the order of my key is 3 by 3, I have to choose my plaintext in the order of 1 by 3. So what I will do, I will divide this plaintext in order of 1 by 3. So this will be my first plaintext, let's say it x1, and this is my second plaintext, so let's say it's x2. Okay, so for encrypting the plaintext, I will take one of the plaintext, so that is encryption for x1, which is denoted by y1. And what's the formula? Formula is x into k mod 26. Okay, so my x here is 2, 17, 24, and k is 10, 5, 12, 3, 14, 21, 8, 9, and 11. Okay, I have to multiply both the matrix and take mod 26. So if you multiply this, you will get a matrix of order 1 by 3. So multiplication is 2 into 10 is 20, plus 17 into 3 is 51, plus 24 into 8 is 192. Okay, this is my first term. The second term is 2 into 5 is 10, plus 17 into 14 is 238, plus 24 into 9 is 216. Okay, this is my second term, and the third term is 2 into 12 is 24, plus 21 into 70 is 357, plus 11 into 24 is 264. Right, now you have to take mod 26 of this. So if you solve this, what I can do is I can take -1 instead of 51. That I have already explained how to take mod and how you can use it on each and every term. So for 192, you can do is 192 minus 130 is 62. 62 means it's 10. 62 minus 52. So 30 minus 1 is 29. 29 mod 26 is 3. Right? So use your own method to solve it. Don't follow me. The method whichever method you prefer, just use that. Even you can add all the number and divide by 26 to get the remainder. That will be a modulus. So follow whatever you prefer, and I will solve according to my method. So 238 minus 130 is 108. 108 minus 104 is 4. Okay, so now 260 minus 130 is 86. 86 minus 78 is 8. So this will become 22. And last one is 357 is 260 is 97. 97. I will take it as minus 7. Then 264 minus 260 is just 4. Okay, so 28 minus 7 is 21. So you can write this 20 mod 26. Okay, so if you will see the value of this, it will be D. Then 22 is 1 minute. 22 is W and 21 is V. So CRY is changed to DWV. Okay. Now let's find encryption of X2. So Y2 is equal to, my X2 is 15, 19, 14 and my key is 10, 5, 12, 3, 14, 21, 8, 9, 11. Okay. If you multiply this, you will get 150 plus 57 plus 112. Then second value will be 75 plus 266 plus 126. And third value will be 180 plus 399 plus 154. Okay, you have to use mod 26 here. Let me divide this so that there won't be any confusion. Okay, so if you solve this, so 150 is 20, 57 is 5 and 112 is 8. Okay, so 28 means 2 plus 5 7. This will become 7. Again 75 is minus 3, 266 is just 6, 126 is minus 4. So 6 minus 7 is minus 1, that is 25. 180 is minus 2, 399 is 13 and 154 is 24, that is minus 2. So this will become, that I did some mistake again. So 399 is not 13, it's 9. This is 9 because 390 divisible by 26, so remainder is 9, and that this will become 5. So if you see it in words, the 7th number represents H, 25 represent Z and 5 represent F. Okay, so your crypto is encrypted to not B, it's D. D, W, V, H, Z, F. This is your cipher text and this was your plain text. So this was the part of encryption. Now I will move to decryption part of this. So for decryption we have to find K inverse first, because formula for decryption was x is equal to y into k inverse mod 26. Okay, I will keep this here. So this was my y2 and this was my x2. Okay, I will use that, but before that I have to find k inverse. So let me find k inverse. K inverse is defined as mod k inverse into adjoint of k. Okay, this is the formula for k inverse. So let's find adjoint of k first. Adjoint of k means cofactor of k, and you have to transpose it, right? So let me write down k here again, then we'll find cofactor of k. K was 10, 5, 12, then 3, 14, 21, then 8, 9, 11. This was my k. So if you are finding cofactor of k, what you have to do is you have to find cofactor of each sum. So for 10 the cofactor is 14 into 11 minus 9 into 21. Okay, 14 into 11 minus 9 into okay, so it's 9 into 21. The second term with a negative sign. So 5 is equal to 3 into 11 minus 8 into 21. Okay, and similarly third term will be for 12 it's 3 into 9 minus 8 into 14. Okay, now this will be negative. So in 3 by 3 matrix the sign moves as positive, negative, positive, negative, positive, negative, positive, negative, positive. So just alternate sign will be always changed. If you see like this also, it's positive, negative, positive, negative, positive, negative, positive, negative, positive here. Okay, so for 3 you have to don't see this row and this column, so remaining is 5 into 11 minus 9 into 12. I will write it down, 5 into 11 minus 9 into 12. Okay, this one is positive, so for 14 it will be 10 into 11 minus 8 into 12. And this one will be negative, whose value is 10 into 9 minus 8 into 5. Okay, again I will write this value. For 8 the value is 5 into 21 minus 14 into 12. Now for 9 it's 10 into 21 minus 3 into 12. Now this one is negative. And for 11 it's 10 into 14 minus 3 into 5. So this is the cofactor and I have to finally take transpose of this matrix, that will be adjoint of this matrix. So if you solve this matrix you will get values as 17, 5, 19. I have already solved it, so I won't waste time in solving this. You can always practice it. So 17, 5, 19, 1, 14, 2 and 15, 8, 21. 15, 8, 21. So if you take transpose Here is mod 26. If you take transpose, its value will be 17, 1, 15, 5, 14, 8, 19 to 21. Okay, so this is my adjoint of k. Now I have to find determinant of k. Okay, so the one method of finding determinant of k is what you will do. You will take one value, one row, consider just any one row. So I'm considering the first row. Okay, so first row into cofactor of this element plus 5 into cofactor of this element plus 12 into cofactor of this element. So as we know, the cofactor for 10 is 14 into 11 minus 9 into 21. Okay, that's what we did here also. So instead of solving this again, what I can do is I will choose these value because these are cofactor of that element. So instead of finding again, I will just write 17, 5 and 19. So if you solve this in mod 26, you will get as 7 mod 26 value. 7 mod 26. Okay, and then we have to find k inverse, that is equal to 7 inverse mod 26. I have already solved this equation 3 or 4 times in the previous videos, so I'm not going to solve this equation. You can always go for its solution, that is 7 to the power 5 of 26 minus 1 mod 26, and finally the value which you will get is 15. Okay, so k inverse is 15, and this is mod k inverse, and this is my adjoint of k. So what I have to do is I have to find the value of k inverse. So value of k inverse is k inverse is defined as mod k inverse into adjoint of k. Okay, so this is equal to 15 into the value of adjoint of k, that is 17, 1, 15, 5, 14, 8, 19 to 21. This is the value I'm getting from here. I've already found adjoint of k, I'm using it here. So it's a scalar multiplication, so every element will be multiplied by 15. So if you multiply it and solve for mod 26, you will get k inverse as 21, 15, 17, 23 to 16, and 25, 4, 3. I'm not showing you the solution. You can always try and verify your answer from here. So now I got my k inverse, and if you remember that I have already found my y1 and y2. Okay, so value of my y1 was value of y1 is 322, 21. Okay, so I will write it down. Okay, so it's 3, 22 and 21, and value of y2 was 7, 25 and 5. 7, 25 and 5. So now we got all the things which is required for decryption. So I will start decryption now. So okay, we keep till here. So as you remember, this is my k inverse and these are my y. So for finding x1, what I have to do, I have to do decryption of y1, and decryption of y1 is y1 into k inverse mod 26. So let's use this. Y1 is 3, 22, 21, and my k inverse is 21, 15, 17, 23, 2, 16, 25, 4, and 3 mod 26. Correct? So what I will do, I will multiply this row by first column. Okay, so 3 into 21, that is 60. This is 63 plus 22 into 23, so that is 22 into 23, let me write it down like that only, to 23 plus 21 into 25. This will be my first term. Now second term is this row into this column. So 3 into 15 is 45, plus 22 into 2 is 44, plus 21 into 4 is 84. Okay, and my third term is 3 into 17 is 51, plus 16 into 22, so that will be 354, 352 I guess. So okay, and 21 into 3, that is 63. Okay, so I have told you how I solve it. So I solve it like 63 is 11 plus, now see, 23 can be written as minus 3. So 22 into minus 3 is minus 66. Minus 66 plus 52 is minus 14. So that can be written as 12. Right? Plus, you don't have to multiply it. You can take 25 as minus 1. This will become minus 1. So minus 1 is, sorry, minus 21. So minus 21 is plus 5. You can always use these tricks to solve this equation. You don't have to multiply, add, and then find the modulus. Okay, this was the first term. Second term is 45. I can write as minus 7. 44 is minus 6, and 84 is 6. 78 plus 6 is 84. And then 51 is minus 1. 352 you can write as 352 minus 260 is 92. So this will be plus 14. And 63 is 11. Okay, so you will get a value of 11 plus 12 is 23 plus 5 is 28, so this will become 2. Okay, and so this is minus 12 minus 7 minus 19. So minus 19 plus I think I did some mistake here. This minus 44 is minus 8, not minus 6. This is minus 8, and this one 84 is plus 6. Okay, so if you solve this, you will get a value of minus 9 which is 17. Okay, and 14 plus 11 is 25, minus 1 is 24. So this is the value of x1 we can verify is 217.24 I am getting, and actual value of x1 was 217.24, right? We got the value of x1 correct. If you solve for x2, similarly you can do that. So let me try that also. So x2 is decryption of y2, which is y2 into k inverse mod 26. Okay, so I can write this as 7 25 5. This is my y2, and my k inverse is 21 15 17 23 2 16 25 4 and 3. Okay, if you solve this equation you will get 21 into 7, sorry, 21 into 7, not 3, 21 into 7 plus 25 into 23 plus 5 into 25. Okay, this is my first term. I will write my second term down. 7 into 15 is 105 plus 25 into 2 is 50 plus 5 into 4 is 20. And my third term is 7 into 17 is 119, I guess. Okay, plus 25 into 16 is 400 plus 15. So I will solve it. So 21 I can take as minus 5. So minus 5 into 7 is minus 35. Minus 35 plus 26 is minus 9. So minus 9 can be written as 17. Right? So 17 plus, now this is 25 into 23. 25 I can always write as minus 1. So minus 23, that is 3. Plus this 25 is minus 1. So this is minus 5. So minus 5 can be written as 21. Correct? Now 105 is 1 because 104 is divisible by 26. Plus this is minus 2, 50. And I will keep 20 as it is, plus 20. Okay, and the third term is 119. So 119 is 15 plus 400 is 10 because 390 is divisible by 26 plus 15. Okay, now I will solve this. So 17 plus 3 is 21, 20, and 21 is minus 5. 20 minus 5 is 15. I'm getting 15. Second is 1 minus 2 plus 20. So 21 minus 2 is 19. And third term is 15 plus 15 is 30. 30 is 4 plus 10, 14. So this is value I am getting while decrypting the y2. So let us verify if I am getting correct value. So my value is 15, 19 and 14. Actual value was 15, 19 and 14. So we have successfully decrypted our ciphertext. So this was one of the example of Hill cipher, but if you want to command Hill cipher, you will have to practice many questions because you can do many mistakes in this Hill cipher. So that's all for this video. We'll meet in next video. Thank you for watching this video and have a good day.